Hello. So let's talk about a very different area, that's oxidation reduction. So this is the question. So among the following, which is a strong oxidizing agent? So before moving on to the question, let's talk about the concepts of oxidation reduction. What is the concept? Over here, there is an element A. A got electrons and they lose electron. They loses the electron. The process of losing an electron is referred to as oxidation. And the compound or the element which lost its electrons, they called it as a reducing agent, and the compound received as output, they termed it as oxidized. The element A is oxidized because it loses an electron. Over here, I got another compound B. It gains an electron. The process is called reduction process. And the final outcome, I received an electron. So that's why they call it as reduced. The guy who loses an electron, they called it as oxidizing agent. This is the overall process of oxidation and reduction. In an equation, oxidation and reduction, if it happens both on the same time, they call it as redox reaction. Let's move on. Back to the question. So among the following, which is a strong oxidizing agent? So strong oxidizing agent to gain the electron. So oxidizing agent to gain the electrons, so it will go for a reduction process. So over here I got iodine, chlorine, fluorine and bromine. So among this one, the guy fluorine will displaces any of the other halogen atoms. So the answer is fluorine. So this is an answer. Let's move on to a very different area, that's halogens. So before going to the question, let's talk about halogen. What is halogen? Halogens are nothing but the elements which it reacts with the other element, it will become salt. It will form salt. The other name of halogen is salt formers. Okay, let's move on. The halogens are nothing but you got fluorine, chlorine, bromine, iodine and acetine. So these are the 5 things available. So they react with alkali metals to form salts, and they got 7 valence electron in the outer orbit. They got 7 valence electron. Okay, so this is one of the very important one. So 1 electron is pending, right? They are ready to gain that electron to form any kind of compounds. Okay, so halogen atoms only need 1 electron to fill their outermost energy level. They are easily react with anything, and they are basically diatomic. What is diatomic? It's nothing but fluorine exists in F2, chlorine exists in Cl2, bromine exists in Br2, iodine exists in I2. So this is how they are diatomic property. They got diatomic properties. Okay, on the other hand, they are found in nature. You are able to extract it in nature itself. Let's move on to the question. Now, which is a strong oxidizing agent? I've told fluorine, right? Yes. Okay, let's move further about like halogens further. The reason is like these are all some of the questions they will ask in your exams. They may ask in a different perspective, like how did it exist? Iodine and acetine exist in the form of solid. Bromine, it exists in the format of liquid. Fluorine and chlorine, it exists in the format of gas in nature, by nature. Okay, if you talk about the uses, these are all very important uses of fluorine. It's used in, they'll be asking fluoride toothpaste and everything. So it's used in toothpaste, water treatment, extraction of aluminium, non-stick coatings and enrichment of uranium. Mark down everything. These are very, very important answers. You should note it down. And considering chlorine, obviously chloride water. to clean up the water. Okay, so it's a water disinfection. It's used for preparing hydrochloric acid, plastics and bleachers. Bromine is used in your photographic films. Okay, obviously photographic film, tear gas, flame retardants and pharmaceuticals. So they are used in medicine preparation also. Obviously the final one is iodine. So iodine is used in many areas like a disinfectant, thyroid treatment, cancer treatment, salt additive, X-ray diagnosis and halogen lamps. These are all very important uses of these elements. Please make a note of it. They may ask in the exam. And the entire halogens are available in 17th group and they are salt formers. So they will form salts and the oxidation number is -1. So that's it. This is the one you have to understand about halogens. Now let's talk about the periodic table. Okay, so periodic table, they may ask a very different question. Let's solve this one also. Over here you are able to see you got the periodic table elements and these are all called as representative elements. These are all called as representative elements. Okay, and this is called S block and this one is P block and this one is noble gas and this one is like your halogens. Over here you should understand these elements are called as transition elements or D block elements. And there is one group which I missed it, that's called lanthanides, and one group which I missed, they called as actinides. That's why they called as inner transition elements, F block. That's how your periodic table is. Further moving toward your periodic table, this is how the entire periodic table, a clear structure is. What is the structure? If you start thinking, every element is indicated in this format. So this is a format of an element. So you got the symbol here, for example hydrogen. The symbol here, the name is indicated in the bottom, it's hydrogen. And if there is any electronic configuration, it's placed here 1s1. So they'll give that electronic configuration at the bottom. On the other hand, over here you got the atomic number, that's 1. And over here you got the atomic weight. What is the atomic weight? 1. And bottom you got the oxidation state. What is the oxidation state of hydrogen? So this is how the elements are indicated in your periodic table. So just note it down. On the other hand, let's talk about the names and the type of elements available. Over here I've indicated this one, the yellow color, it's nothing but your alkali metals, and this one is your alkaline metals, and this one is your transition metals, and over here is lanthanides, and over here is actinides. And over here this color indicates these are all poor metals, and these are all considered as non-metals, and this one is nothing but your halogens. This is how the type of metals are available and how it exists. So this is the final one I'm going to show you how it exists. So the brown color, the black color indicates the element with the black colors indicates it exists in the form of solid. It's very important, you should make a note of it. It's very important one. So the element with the black color indicates it exists in the solid stage, and the elements available in this green color indicates they exist in liquid stage, and the elements which is available in the brown color format, they indicates they are in the format of gas. And finally there are some elements which is in the format of ash color, indicates they are in a format of synthetic. That's how it's available. So we got lots and lots of questions with answers in our YouTube channel Kashu Academy. Okay, almost 20,000 questions I've solved it personally, and it's available in our Kashu Academy YouTube channel. You can subscribe to the YouTube channel to get the latest updates from us. Thank you.